All right, so we are recording this meeting. It'll be available for everybody, but there are a couple people who were not able to join the video part, and so I wanted to make sure that everybody has access to all of that. And let's get started. Okay. So I know that some of you haven't submitted your practice test yet. Please get that done and get that to me as quickly as possible. We're going to use some of that data to drive our review week, and also to see what we need to focus on, if there's anything we need to get back to, or if everything that was on the test that you weren't comfortable with is stuff that's coming up. So we want to make sure that we cover everything that the test shows you're having trouble with. Any issues from last week that we need to go over? I can't see the if you're raising your hands or anything or putting anything in the chat, I can't see that while I'm sharing my screen. So if you need my attention, please remember you need to unmute and holler at me. Okay, so let's do this first. We are going to tackle some structured ways of looking at word problems, and we are going to go through what when you see certain words, what that means algebraically. And then we're going to do some problems. We're going to do percent of whole, percent more or less, and percent change. I think percent change is the one that people have the most trouble with, I think. So when you're looking at a word problem, any word problem that that involves any sort of any of the maths. So today we're going to look specifically later on at percent word problems. But anytime you're looking at a word problem, you're going to want to identify the information that you're given and then what information you're looking for. And I've got this document that's kind of big, it's kind of long, which is why I didn't include all of it in here. I just wanted to give it to you, and I'll give you the link to it. It's a Google document right now. But if you see these words in a word problem, this is the action that it signals. So it's the second column is what you will see in a word problem, and the first column is what function that indicates. And some of it is pretty straightforward. Subtraction is a booger, because oftentimes when you are writing it or reading it, the subtraction is backwards. So it gives you the, like, it'll say 6 subtracted from a number. That's not the way we write it. We write it with the number in the front, so we would write it as x minus 6, but in the word problem, it's going to be the 6 is going to come first. You just have to remember to flip that around when you're doing it. But I will give you, don't worry about trying to write this down or remember all of this stuff. I will give you access to this document. And I bet y'all couldn't see that, could you? Okay, so.
Yeah, no, we couldn't see that because I was trying to follow you.
Yeah, I just realized that. No, you're fine.
Okay, all I have to do, we click on phrases, right? And then that'll bring up.
Right, it'll bring it up when you get a copy, when you get your copy of this, but I will also send you that link separately. so you can download it. Let's see. Do you want to take it? Do y'all want to see it right now? Because all I have to do is unshare and then reshare. Okay. Stop sharing. Go to this. And reshare. Now, can you see it?
It's definitely there. Yeah. We
Okay.
can't read it though. You can probably.
Gotcha. Okay, it's too small. Gotcha. I will share this with you. When I send out the PowerPoint, I'll send a link to this as well.
Okay.
All right. So Tom has 25 Bumblebee marbles and Marcus has a few more than Tom. If they have 56 marbles in all, how many Bumblebee marbles does Marcus have? So first thing you want to do is identify the information that you're given. And can you guys see the PowerPoint, or is it still on the?
It's still on phrases.
Okay. I have to unshare and reshare. Okay. We should be back on the PowerPoint together. So the information that you're given, you know that, or they tell us that Tom has 25 marbles and that together Tom and Marcus have 56 marbles. And what we're looking for is how many marbles does Marcus have? The mouse is still misbehaving. So when you write an equation, you can do this a couple different ways. You can say 25 plus Marcus's marbles equals 56, or you can write it as the total 56 minus 25 equals Marcus's marbles. And in solving it, you're going to get the same answer. It's just important that you isolate the information that you're given, and sometimes they'll give you extraneous information, and you will scratch your head thinking, what am I supposed to do with this? And they're just giving it to you to make sure that you can isolate what's really important that you use. So just in general, when we're doing word problems, what information are you given and what is the question actually asking? So when we are doing word problems, one of the challenges is figuring out what the words mean. So if you have a phrase like 2 times the difference between 7 times x and 4. Now that's going to take some work. So we know we're going to write, it's going to be 2 times something. And the difference means that we're going to be subtracting something. And 7 times a number looks like this. Two times the difference between 7 times x and 4. Does that make sense?
Yeah, it makes sense. I might, let's see, 2 times the difference between 7 times x and 4. That and might have might have gotten me off a little bit. I might have tried to do 7x plus 4. But so when you say difference, I think of subtraction. So I'm like, is that where that
yep,
subtraction is? But forget about the word and.
yes. They just put the word and in there because it's the second part of the difference.
Okay.
The difference between 7 and 4, or 7x and 4.
Oh.
Now in the next one, the and, well, I guess it's still the same. It's the same sort of configuration. So for this one, and let's change colors. So quotient means that we're going to be dividing.
Right.
And the first part of it is this. So we've got 2g minus 9. And that's all. So the and is what's telling you that the next part of the quote of the division problem is coming up.
Oh.
So I don't know how often a problem like this is going to come up. But if you know the keywords like difference and quotient.
I feel like it's just a little confusing, that and part, because this might not really make a difference of what it is,
No.
but would it make more sense if it was saying over 3? Or would it at all say over 3, or is it just going to be and?
It's just going to be and I'm trying to think if there's an absolute that I can tell you about that. It's possible that if you were given a problem, they wouldn't, because it would be a word problem, they wouldn't phrase it like this. So they would say, like, all of the bits and pieces would be part of the story. Like there would be 3 people and you would have to figure out how much each one of them did or how much each one of them had. And so that's would be your trigger to divide by 3. So unless it's just a straight up problem where they want you to go from words to algebraic expressions, which is what this is, if it's in a word problem, it's probably not going to be this stilted. It's probably going to be built into the story more than it is just lining up the mathematical phrases. Does that make sense?
Yes, it does.
Okay.
So
go ahead.
So Samantha, in this case, when you were talking, I consider like that bar and as some kind of rule.
Yes. Well, it's
but now
the quotient.
Yeah.
Because I wanted to write it as a fraction, write the quotient. You could also write this as 2g minus 9, but if you're going to do it horizontally, you got to put the parentheses there. So it's not 9 divided by 3. It's that whole quantity divided by 3.
And so in a sense, those brackets could represent the word and.
Well, the word quotient is what triggers division. So the and, in both cases, the and telling you that this number is the second part of the expression.
Okay.
Okay. So five multiplied by the sum of twice D and 10. So sum means that we're adding. We're going to add 2D and 10. So sum means addition. So the Delta Math has some practice with this. And you can always do more problems than the ones that are assigned. I think it is important that you reach a comfort level with deciphering these kinds of things. Like I said, I'm not sure how many of them will actually appear in this format in the test, this format versus being a word problem, which is not quite as mathy. Like they would say, if you have 5 buckets and each bucket holds double the number of cups plus 10 more. It would be the same sort of equation, but it might be a little bit easier to decipher in the story version.
Samantha, I think they sometimes put this type of the the wording, you know, when
right.
you read the I think they do that, you know.
Yeah, and that's why I put it in the Delta Math. And it might wind up being something that you want to do extra Delta Math on, just to be comfortable with it. And you know, sometimes tearing it apart makes it a little bit easier, doing a little bit like doing it pieces at a time, like I did. Like as soon as it said quotient, I went ahead and drew the line because I know that means a division problem is coming up. So just getting comfortable with what those words are telling you to do. And you will get comfortable with it, I promise. But, and you know, one of the nice things about Delta Math, if you get stuck, there's a video, or you can just ask them to solve the problem and they'll go through it step by step with you to show you how to do it. So, all right, I know that I need to stop sharing and come in here. Turn this on. Turn that on. And then go back to sharing. Okay, can you get, yeah, you guys should be able to see the study.com video that's coming up.
Yes, we can see.
Okay, stay unmuted for just a second and let me make sure
$525
that you can.
But now since it'll cost Meet Ashley.
Can you guys
Here's
hear?
Ashley's house.
You can hear it?
Yeah. Yes.
Okay.
It's what you might call a fixer-upper. She could definitely use some help. In this lesson, we're not going to help Ashley redo her floors or paint, but we will help her with some percent word problems. These problems are about as common as the termites in Ashley's walls. What? She didn't know there were termites? Oh no. Well, while she fumigates, let's talk about how to solve these problems. First, the word percent just means per 100. If you have 100 nails, 50% of that is 50 nails. If you have 8 paintbrushes, 50% is 4 brushes. To figure this out, we can set up a simple equation. 50 over 100 equals x over 8. 50% is the same as 50 over 100. In a percent word problem, we follow a few steps. First, read the entire problem. Makes sense, right? Next, identify the question. We can't solve it if we don't know what it's asking. Third, identify the relevant details. This can be the tricky part. We're looking for a few key things. We might see a percent, which is identified with this symbol. Unless that's what we're trying to find out. There might be a whole or a part. A whole is the original number. In our paintbrush example, 8 is our whole. This is also sometimes called the base. 4 is our part. That's part of the whole, or base. It's important that we figure out what's what so we can get to step 4, solve the problem. As we'll see, there are often different, equally effective ways to solve percent problems. It's like fixing a leaky pipe. As long as you make it stop leaking, it doesn't matter if you solder in a new section or just put gum on it. Well, okay, gum isn't a long-term fix, but in percent problems, you may have multiple options. All right, time to help Ashley. She's retiling a bathroom and she runs into this problem. A bathroom requires 470 tiles. If Ashley has 355 tiles, what percent of the bathroom tiling can she complete? Let's think about our steps. We read the problem, and what's the question? We're trying to find the percent of the bathroom she can tile. What details do we know? We know the whole, that's 470. That's the total number of tiles she should have. We also know the part, 355. How do we solve it? There are a few different ways, but let's try an easy one to remember. Let's compare the part to the whole. So we have 355 over 470 equals x over 100. Here, x is the percent of the tiles. 100 would be all the tiles, which is 470. To figure out what x is, just cross multiply. So 470x equals 35,500. Divide by 470, and x equals 75.5%. And that's our answer. Sadly, that doesn't cover the walls with tiles, but at least Ashley knows how much coverage she'll have. In that problem, we found the percent. What if we need to find the part? Ashley's at the hardware store and she encounters this. A table saw's original price is $250. If it's on sale for 15% off, what is the sale price? This time we want to find the part. The sale price is going to be a part of the whole price, which is $250. We know the percent, 15. But be careful. The saw is 15% off, so the part we're trying to find is 85% of the whole. Okay, with that in mind, we could set up two fractions again, but there's another, simpler method. Let's convert 85% to a decimal. To do that, we just drop the sign and move the decimal point 2 places to the left, so it becomes 0.85. Now we can multiply 0.85 times the whole, 250. That gets us $212.50. So our sale price is $212.50. Ashley was psyched to find a deal on a table saw. She hopes to also score a deal on some drywall. She needs a lot, and here's what she learns. A hardware store has 30% of its drywall on display, with the rest stored in the warehouse. If 72 panels are on display, how many in total are available? We're trying to find the total number of drywall panels, so we want the whole. We know the part, 72 panels, and we know the part is 30% of the whole. Let's try a new method. We can call the whole x. We know that 30% times x is 72. In other words, whatever x is, 72 is 30% of that. If we turn 30% into a decimal, our equation looks like this. 72 equals 0.30x. Now we divide by 0.30 and we get x equals 240. So the store has 240 drywall panels, including those on display and in the warehouse. That'll cover a lot of wall. Let's try one more kind of percent problem. This one involves some electrical work. Sparky the electrician originally said his labor would cost $525, but now says it'll cost $610. By what percent did the cost increase? Before we can find the percent increase, we need to find the change in dollars. 610 minus 525 is 85. So Sparky's charging $85 more. We can find the percent with a little division. To find percent change, divide the absolute change by the original. This works for increases or decreases. Here our original price is $525, and our difference is 85. 85 divided by 525 is 0.16. If we convert that to a percent, it's 16%. So $525 to $610 is a 16% increase. Let's hope Sparky spends that money on some safety equipment. To summarize, we learned about solving percent word problems. Percent just means per hundred. When we solve these problems, we follow 4 steps. First, read the problem. Next, identify the question. Third, identify the relevant details. This includes looking for things like the percent in question, the whole, and the part. Finally, solve the problem. We looked at different ways of solving these problems, including setting up 2 fractions, converting percents to decimals, and using a variable to stand in for our missing number. And maybe, just maybe, we helped Ashley fix her house. It's got to be at least, what, 5% better?
Okay. Okay, so there are lots of different ways that you can solve or set up percent word problems. I like to keep it simple, and this works for everything except for percent change. So you're going to be given 2 parts of this equation, and you're going to have to solve for the third part. So the trick sometimes is figuring out which part you're given and which part you're solving for. So if you're looking for the percent of the whole, a concert hall has 400 seats, of which 325 are occupied. What percent of the seats are occupied? So let's use yellow. So the part is 325 and the whole is 400. And we're trying to figure out what percent that is. So this, I'm so sorry, is the cross multiplication that we do. And that leads us to this equation. So you get 400x equals 32,500. And then the next step is to divide both sides by 400. And so 32,500 divided by 400 equals. So x equals 81.25, and I would round that down to x equals 81%. And you can choose, you can look at the answers that are given, and if it tells you to round to the nearest hundredth or whatever, to decide whether or not you round. I don't like decimals in percents, so I rounded down. Okay. Each day, a bakery makes 50 loaves of wheat bread. If that amount is 20% of the bread they make, how many loaves do they bake each day? So the pieces of information that we have, the 50 loaves is part, and we've got the percent. So when we set this one up, 50 is going to go on top. We're trying to find out how many the total is equal to 20 over 100. To divide both sides by 20. Okay, so percent of works the same way. So you're given the part. And this time it's actually a little easier. Oh, that's a horrible number. So you can do that a couple of different ways. You can do it like this, or you can divide 86 divided by 0.7. See what? How about if I jump out of this? I wonder if you guys can. Okay, I'll just keep doing the work. But you guys follow along with this, please, and do it. And don't just watch me do it. Do it on your own too. And if we don't come up with the same answer, let me know. So we've got 80 over x equals 55 over 100. These are just horrible numbers. So you can do this as 80 divided by 0.55, or you can do the cross multiplication. Which is the same math, it just is written differently. Okay. So 88% of 41. We don't know what it is, but we know that the whole is 41. That's 80. Somebody have a question?
Yeah, I'm not seeing what you're sharing.
Let me make sure that I'm sharing. It's entirely possible that I'm not sharing.
Okay, thank you.
You're welcome. Thank you for letting me know. Okay, so this time we're going to have $100x equals, what's 41 times 80? 3,608. And if we divide that by 100, we get 36.0. Okay. All of these problems work with, if you set it up as part over whole.
Just a quick question. It means we are just read carefully and then plug in this, in that equation,
Right.
Part over whole equals percent over 100.
Correct.
Yeah, because 86 is 70% of what? It means I have a part, am I right, over whole. Whole is
correct.
And then it's 70% over 100. And the last one, what is 88% of 41? It means I have a whole, part is X, and then I plug in this 88 over 100. Okay.
Right.
Yeah, just need to be,
yes,
the wording
absolutely.
when I'm reading. Yeah.
I have a question. So I followed you for the first two, and then I couldn't follow the wording of the math with the second one. So what is 88% of 41? Okay, and we deal with the part and the whole. So, okay, in your first part, you have X, which is the part over the whole. No, is that it?
Yes.
Okay.
Because you're looking for 88% of 41.
Okay. So X.
So we're looking for the part.
And the part is 41?
The whole is 41.
I meant to say, yeah, the whole is 41.
Yeah.
And then equal, and then the part is 88 over the 100 because of the decimal. And then you did the math. But what about the other part? 100x over 100 equals, I'm probably missing one little sentence.
Well, because I multiplied 41 times 88, and that's 3,608.
Okay.
And so we're going to divide both sides by 100.
Oh.
So we have x equals 3,608 divided by 100.
Okay, I'm gonna have to practice that one. It's just the steps. It's just the steps. That's good. That's good.
I have a question as well.
Okay.
Well, I guess this is really just clarification. So are you saying that we can do either one? We can do the 86 over x equals 70 over 100 equation, or we can do 86 divided by 0.70 to get x?
Yes.
Okay.
Good.
Yes. It's the same math. It's just cutting out one step. If you do the 86 divided by 0.70, which is 70% turned into a decimal.
Okay.
But both of them will work.
And what you're doing is going to be on the PowerPoint, right? Because I think you've done it like that way before.
Yes.
Yeah, and that's why I wasn't doing the problem. I was watching you do it and then
And that's fine.
Okay, because I knew you talked about we should be doing it, but
Yeah.
okay, this is better.
If you're more comfortable just watching me do it, and you'll get lots of practice in Delta Math.
Okay.
Very confident that if you need to see more. Okay. So percent more or less. Amelia invests money in an account paying a simple interest rate of 2.1% per year. If she invests $130, no money will be added or removed from the investment. How much will she have in 1 year in dollars and cents? So this has two steps. So the first step is to find out what 2.1% of $130 is, because they're assuming that we all understand how interest works, that when you have your principal, 2.1% of the principal is going to be added back to it per year. So we've got x over 130, because we're trying to figure out what 2.1%, decimal in a fraction. I hate that. Okay. And my decimals aren't showing up. So I would do the shortcut way. No, I'm not. That'll just confuse me. 100x. So I'm not going to do the shortcut way. I'm going to cross multiply. Equals 130 times 2.1. Where does that decimal go? So x equals 273 divided by 100. X equals okay. So now we've found out what x equals, and now we know that 2.1% of this $130 is $2.73. But what the question is asking is how much will the total be after a year? So now we're going to add 2.1% to 130. So she'll have 132.73. She can go buy some eggs now. Okay. Does that make sense?
Yes.
Okay. Okay.
Just have to practice. Oh my God.
Okay. Stella went shopping for a new camera because of a sale. The store was offering a 20% discount if the price on the tag was $23. Where's she finding cameras for $23? What would be the price after the discount, but before tax? So we're not going to worry about tax. We just want the price after they take the 20% off. So we're going to yeah, we need to find out the 20% first. I'm doing it backwards. So the discounted amount is going to be $4.60. So doggone it. Quit. Is that right? So we would subtract. Go ahead.
So with $23, yeah, I can understand that. And then the 4.60, I understand that. We're trying to now see what would be the price after the discount to the nearest dollar and cents. So what was the trigger for us to know that you're subtracting 4.60 minus $23?
Because this is the discounted amount. The 20% that they're taking off is $4.60. So we're going to take the original price and subtract $4.60 from that.
Okay. Okay. Thank you.
Oh, that's the part I always forget to subtract, what I get, multiplying, and then I need to subtract from the original price,
Right. But if you were doing it in the store, if you were standing in the store doing it,
yeah,
you would remember to, because you know that the price is going to go down.
Yes. Yeah.
So it only makes sense to subtract.
Yeah. That's a loss. Okay. Thank you.
Oh, I don't know why I put a black slide there. Okay. Percent change. This is the one that the formula makes sense when you plug all the numbers in, but just remembering which number goes on the bottom, which your denominator is going to be your original number. So let's take a look at last year at a certain high school. There were 56 boys on the honor roll and 150 girls on the honor roll. This year, the number of boys on the honor roll decreased by 25%, and the number of girls on the honor roll decreased by 12%. Okay, so let's put, did I put it in there? No, I did not. All right. So I'm going to put it in there. So we do old number minus new number, and then we divide that by the old number. Okay, so first thing we have to do is figure out the old number. So it's going to be 150 plus 56. So there were 206 kids on the honor roll to begin with. And the number of boys decreased by 25%. So I know I just showed you a fancy way to do that, but there's a trick. I'm not going to show you a trick. That'll just be confusing and mean. I'm going to do it the long way. So over 56 equals 25 over 100. X equals 14. So the new number of boys is 56 minus 14. And that's 42. And then the number of girls decreased by 12%. So, sorry. X over 150 equals 12 over 100. So the new number of girls equals okay. So this year, which is not a good year for us academically, there are 132 plus 42. There are 174 kids on the honor roll. So now, I'm going to do it right over here. We're going to take 206, which is the original number, and we're going to subtract the new number and divide by the original number. So 206 minus 174.
We can't see your writing.
Can you see the 206 minus 174 over in the corner?
Yes.
Okay. I'm just running out of room. And I'm going to switch colors. So this is 32 over 206. Equals point. Oh, they want it to the nearest tenth. Okay, and I'm late. And so I'm going to finish this. 15.5%. This was a terrible example. And it's a terrible example because there was a whole lot of stuff in there besides just the percent change. So, and once again, you will get plenty of practice and helpful videos on Delta Math, but old number minus new number divided by old number is how you get percent change. And, go ahead.
Do you think you can clarify for me a little bit more why it ended up being 15.5?
Absolutely. So right down here, I took the original number and I subtracted the new number and I got 32. So the difference is 32. That's how many fewer students are on the honor roll this year than last year. And then I divided that by 206. And that number is 0.155. And then to turn that decimal into a percent, I multiplied it by 100, or I just moved the decimal 2 places to the right.
Did you move it 2 places because it says to round to the nearest tenth? Because I originally just put 15%.
Yeah, well, and I would have, except that it said to round it to the nearest tenth. So
move it 2 places to the right if it's saying nearest tenth.
Well, I mean, move it 2 places to the right regardless. When you multiply times 100, you're going to move 2 places to the right. But I went back and picked up that 0.5 because they asked us to do it to the nearest tenth.
Okay, understood.
Okay. And then I'm looking at, I know it's real simple. This is what I got to practice. You know where you have x over 56 equals 25 over 100? Mm-hmm. So you kind of skip those steps, which I understand is probably easier for some folks, but for me, I have to go really step by step. So that
I multiplied.
I'll show you. 50. Okay, you're showing me. Let me be quiet.
I multiplied.
Right, and that would have given you 1,400. So x over 100 equals 14 over 100. 1,400 over 100.
Nope. Okay. It's 100x equals.
Got it.
And then I divided both sides by 100.
Yes. Okay. And that's how we got 14. Okay, good. I see it. Thank you.
Absolutely.
I've got to practice that too.
Well, it's in, you know what? When you cross multiply, you just set the two sides equal to each other. And then
Yeah.
whatever you have to do to divide to get x by itself, you
Yes.
just divide both sides by whatever x has been multiplied by, because you want to have x by itself.
Okay. I have a question before we get off. When we're looking at clearing fractions, it had in the Apex book, it had like A over B equals C over D, and then it talked about there was a way to clear a fraction, and I couldn't follow that one.
I'll have to look and see what the heck that means. Clearing is not a mathematical function, so I'm not sure what they're doing. Oh, well, hold on. Are they cross multiplying?
Let me see if I can get back there. Let's see. It just says, I don't know if it says if A over B equals C over D, then to clear the fraction, multiply both sides by the least common denominator. And then it turned out to the common denominator was BD.
Yeah.
Is it kind of like what we're doing here a little bit?
Well, when you're finding a common denominator, the easiest way to find the common denominator is to multiply the two denominators together, because you know for sure that that's going to be a common denominator. It may not be the lowest common denominator, but it'll be a common denominator because you just multiply the two of them together.
Okay, so when it says clear the fraction, even though it says that equal sign between those, that problem, just go ahead and multiply. So here we would have A over B.
We don't want to do that. Right. We don't want to do that here.
Oh. It was just in the book, and I was just trying to, maybe I don't pay attention to that.
Well, clearing the fraction is something different than what we're doing here.
Right. I was just trying to catch us before we got off, because in the reading I wasn't understanding it. That's all.
Okay. Can you tell me what page that's on?
Yes, ma'am, I sure can. It's page 104 in the Apex.
So I will take a look at that.
Okay.
Apex 104 and see if I can add any clarification. And I'll send it out to everybody.
That's good. And even with those triangles corresponding angles and corresponding sides, if you get a chance to look at that, maybe you can put some little notes on that one.
Yeah, well, and that one, we're gonna get to the geometry. We just haven't done that part yet.
Oh,
so why that was in this week.
Because in the Apex it said go to page 104. So I should have stopped at the first part of 104 then?
Yeah.
Like about the first paragraph, I guess. Because there's also that formula, like letters are so small, like M equals Y to Y second minus Y1. There's that formula.
Oh yeah, no. We don't need that yet. That's
okay.
Slope. Yeah, we don't need to worry about that yet.
Okay, good. Because that was in your syllabus to go to 104. That's all.
Okay.
Thank you.
No problem. I'm sorry if that caused some concern.
That's okay. We got to learn it anyway.
All right. So this is this week's stuff.
Yeah.
We're back to our regular pattern. And I'm not going to hold you up because I've already sent this to you and you're proficient readers. So if you have any questions, thank you all for sticking with me. I know I'm running late, and so I owe you guys 10 minutes next week. All right, that's it. Let me know if you have any questions, and I will send this out to you guys tonight.
Great.
Thank you.
I have a last question.
Okay. I got you, Sam.
Oh, shoot, I forgot what I was going to ask you. Oh, are you accepting the reading notes?
Sure.
Because I couldn't submit it for some reason.
Yeah, no, that I got them. I got 2 copies of yours, I think.
No, not today. I was trying to submit it today.
Yeah, I did. I got 2 copies today. For real, like right before the meeting.
Right. Okay.
Yeah, no, it worked. Whatever you were
I was
doing, it
trying to look
worked.
for the part that says submit, and I guess the letters were so large that I couldn't actually see where I was submitting. I don't know what I was doing.
Okay, no, you submitted.
Awesome. Okay, great. Thank you so much, Samantha. Thanks
Thanks.
for your patience.
Absolutely.
Okay, now if I could just find out how to get out of here. Okay.
The little red button up in the upper right-hand corner. Okay. What can I help you with, Sam?
Hi. Are you receiving my notes? Reading
Your
notes?
reading notes? Nope.
You're not receiving my reading notes?
No, sir. It's okay. Unless you have questions about them that you want me to answer, it's fine. I know you're doing the reading.
No, I guess I don't know how to send them to you through that form. So what I do, I just